Math in the house. Today, we're doing math analysis, Chapter 3, Section 3, the unit circle. I'm your host, Dr. D. Okay, the equation of a circle on an xy coordinate plane is x squared plus y squared equals r squared, where r is the radius of the circle. So, the unit circle, the radius is 1, so that means the equation of the circle just becomes x squared plus y squared equals 1 squared, or 1. All right, now, let's take a look at what this means. If x equals 0, then y squared equals 1. That means y equals plus or minus 1. So when x is 0, y is 1 or negative 1. When y is 0, then x squared equals 1. That means x equals plus or minus 1. So we have negative 1, 0, and 1, 0. And then we have all the points in between. So here is the unit circle, x squared plus y squared equals 1. Note, the domain here is x is an element of the interval from negative 1 to 1 inclusive. What does that mean? That means x has to be bigger than negative 1 and less than 1. Why? Well, because if I put a number in bigger than 1, let's say I put a 2 in here. Well, now 2 squared is 4, so 4 plus y squared equals 1. Well, if we subtract the 4 from both sides, then we have y squared equals negative 3. Well, y can't be, you can't square something and get a negative number in real numbers. So that means x can never be bigger than 1 or smaller than negative 1. And likewise, y, the same thing. Y is going to be between negative 1 and 1 also, and that's what you see on the circle. There are no points out here where x or y is greater than 1 because it's a circle with radius 1. Okay. Now, what we want to do is find the points on the unit circle where x equals 1/2. And note the symmetry. All right, so let's look at our unit circle again. So we want the point, or the points on the unit circle where x is 1/2. All right, so x is 1 right here. So x is 1/2 right here. So here are the 2 points. So how do we find what those coordinates are? We know that x is 1/2 in both of these, but what's y? Okay, then the equation of our unit circle, x squared plus y squared equals 1. So we just plug in 1/2 for x. So 1/2 squared plus y squared equals 1. Now square 1/2, you get 1/4. All right, so we're going to subtract 1/4 from both sides. So now y squared equals 1 minus 1/4 is 3/4. Now we take the square root of both sides. So y equals square root of 3 over square root of 4, which is 2. So these are our, oh, and notice when we took square root of both sides, it's plus or minus. So here's the positive square root of 3 over 2. And here's the negative square root of 3 over 2. So note the symmetry. Any x value I pick, I'm going to have a positive y value and a negative y value. And likewise, if I gave you a y value, then there would be a negative x value and a positive y value to that. So there's always symmetry. Now, one other thing I want to point out is when they gave you x equals 1/2, they basically gave you a 30, 60, 90 right triangle. Because here's 1/2, and the radius is 1. So notice my short side is half the long side. And, I'm sorry, my short side is half of the hypotenuse. And it's the square root of 3 times the short side gives me the long leg. So that's how we know that the angle here is right, pi over 3. Okay, that's enough of that. All right, cruising onward. So this is what we were just dealing with here. Special triangles on the unit circles. So we've got what we used to call 30, 60, 90, which is now the pi over 6, pi over 3, pi over 2 triangle. Notice short leg is 1, long leg square root of 3, hypotenuse 2. Now, if we want to put this on the unit circle, then what we're going to do is we're going to make the hypotenuse the radius. And so we're changing it from 2 to 1. That means I have to divide everything by 2. So instead of the 1, it's now 1/2, and instead of the square root of 3, it's square root of 3 over 2. Same thing with our 45, 45, 90, which is the pi over 4, pi over 4, pi over 2 triangle. We have 1, 1, and square root of 2. Well, what I want to do is I want to make the radius the 1. So I'm going to divide through everything by the square root of 2. And now my radius is 1. And this is 1 over the square root of 2, which is same thing as square root of 2 over 2. And this is same thing, square root of 2 over 2. So the hypotenuse of these triangles have become the radius of a unit circle. They're 1. So notice the angle pi over 6, pi over 3, pi over 2. When we cut everything in half, the angles don't change because I have similar triangles. So it's still pi over 6, pi over 3, pi over 2. And same thing here. I have pi over 4, pi over 4, pi over 2. Well, when I shrink the triangle, the angles stay the same. Pi over 4, pi over 4, pi over 2. Okay, cruising onward. So what we've done now is we've put these special triangles inside the unit circle. So notice my radius is 1, the short side is 1/2, and the long leg is square root of 3 over 2. So that means the point on the circle is going to be the x value is square root of 3 over 2, and the y value is 1/2. And so what that tells us then is, here's my angle pi over 6 right here. So sine pi over 6 equals the y value, which is 1/2. Cosine pi over 6 equals the x value, that's square root of 3 over 2. And tangent pi over 6 is y over x, which is 1/2 over the square root of 3 over 2. And the 2's cancel, I'm left with 1 over the square root of 3. And when I rationalize that, I get square root of 3 over 3. Now, the pi over 4, pi over 4, pi over 2 triangle, same thing's going to happen. The sine is the y value. The cosine is the x value. Now let's go through that real quick. Sine of any angle is going to be y over r. But remember, r is 1, so sine equals y. And the cosine of any angle is going to be adjacent over hypotenuse, x over r, but r is 1, so cosine is x. And tangent is going to be y over x. So sine of pi over 4, well, that's just the y value, which is square root 2 over 2. Cosine of pi over 4, that's just the x value, which is square root 2 over 2. And tangent pi over 4 is y over x. So square root 2 over 2 divided by square root 2 over 2. Notice top and bottom are the same, so the ratio has to be 1. Okay, now this is the way the book has presented the trig functions on the unit circle. So what we're doing is we're making, instead of 1, 2, and square root of 3, we're just going 1/2, 1, and square root of 3 over 2. Instead of 1, 1, and square root of 2, it's square root 2 over 2, square root 2 over 2, and 1. Now the advantage of this is that for sine and cosine, sine is just y, cosine is just x. So you don't really have to go opposite over hypotenuse or adjacent over hypotenuse, because the hypotenuse is 1. All right, so find the point on the unit circle associated with each given rotation. So we want the point on the unit circle associated with 3 pi over 4. Well, let's draw that. Where is 3 pi over 4? Well, it's the 45-degree angle in the second quadrant. That's 3 pi over 4. Now, what is the point on the unit circle? Well, it's going to be, notice this is 1, so that means this is square root 2 over 2, and this is square root 2 over 2. Now, what are the signs? Well, notice we're going left and up. So left means negative square root of 2 over 2. And up is positive square root of 2 over 2. So that's the point on the unit circle, is negative square root of 2 over 2, positive square root of 2 over 2. All right, let's try 5 pi over 6. Where's that? Five pi over 6 is pi over 6 short of pi. So here's my 5 pi over 6 right here. Well, what's the point out here? Well, it's a pi over 6, pi over 3, pi over 2 right triangle. So that means the hypotenuse is 1, the long leg is square root of 3 over 2, and the short leg is 1/2. Now, once again, I'm going left and up, so the square root of 3 over 2 is negative. So what is the point right here? The point right here is negative square root of 3 over 2, positive 1/2. So in other words, what we're saying is to hit the 5 pi over 6 angle on the unit circle, you have to go left square root of 3 over 2, up 1, and then that makes this a pi over 6 angle right here. Okay, one more. 5 pi over 3. Where's 5 pi over 3? Well, we have pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. We make our triangle with the nearest x-axis. And so here's 5 pi over 3 all the way around to here. And what we want to know is, what is that point right there? Okay, the short leg is 1/2. The long leg is negative, because it's going down, square root of 3/2. And the hypotenuse is 1 as usual. So that makes this point 1/2 negative square root of 3/2. Now, the key thing with being able to do this is first knowing your angle measures in radians. And second, knowing your ratio of sides with 30, 60, 90 right triangles, 45, 45, 90 right triangles. Okay, cruising onward. Okay, now this last slide is the unit circle, the way I prefer you to learn it. We've been doing the book's way of learning it. I think it's a lot simpler if we do it this way. And that is our 30, 60, 90 right triangle, pi/6, pi/3, pi/2 triangle. The short leg is 1. The long leg is square root of 3, and the hypotenuse is 2. Why is this better? Because it doesn't have any fractions in it. And we don't like fractions. Okay, shut up. Okay, so instead of using the fractions now and having the hypotenuse 1, we're just going to do it the way we've been doing it. Now, what's that going to do? Well, if we look at our pi/6 angle, just like we looked at the 30-degree angle, we have square root of 3 in the x direction and 1 in the y direction, and then 2 as the radius. So technically, this is not a unit circle. That's why I put unit in quotations, because it's not really a unit circle when the radius is 2. But how are we going to do our sine, cosine, and tangent of these angles? Well, let's just take 5 pi/6. What's sine of 5 pi/6? Well, sine is opposite over hypotenuse. So the opposite is 1, and the hypotenuse is 2. So sine of 5 pi/6 is 1/2. Now, I know it's positive because the angle 5 pi/6 is up, and that makes sine positive. Now, if I were to go cosine of 5 pi/6, then it would be adjacent over hypotenuse, so negative square root of 3/2. And notice it is negative because it's left. Now, let's go on cosine 7 pi/6. Well, we're left again, so it's going to be negative. So adjacent is, once again, negative square root of 3. And the hypotenuse is 2. So cosine is negative square root of 3/2. Now, tangent. See, this is where I think my system is easier than the book's, because not only are we doing away with fractions, but tangent ends up being a fraction anyway. If you remember when we did it the book's way, we had tangent was 1 fraction over another fraction. Well, that's a major pain. So now that we've done away with fractions, tangent of 11 pi/6 is just going to be opposite divided by adjacent. So it's negative 1 over square root of 3. And notice it's negative 1 because it's down. 11 pi/6 is down. But it's positive square root of 3 because it's right. And so now if we rationalize that, we have negative square root of 3/3. Okay, now, what about the 45-degree triangles? Well, here we have our pi/4, 3 pi/4, 5 pi/4, 7 pi/4. Those are your 4 pi/4 triangles. And remember, we're making each leg is 1, and the hypotenuse is the square root of 2. So what's the sine of 3 pi over 4? Well, it's opposite over hypotenuse. So 1 over the square root of 2, which makes square root of 2 over 2. Now, is that positive or negative? It's positive because it's up, and sine is positive up. Now, what about cosine 5 pi over 4? Well, that's adjacent over hypotenuse, which is negative 1 over square root of 2. So that makes it negative square root of 2 over 2. Now, why is that negative? Because cosine is negative when you're left. And tangent 7 pi over 4. Well, that's going to be opposite over adjacent, which is negative 1 over 1, which is negative 1. Why is that negative? Because the sine's positive and the cosine's negative. Whenever your sine and cosine are opposite signs, your tangent is negative. Okay, now the third example is where we have the 30, 60, 90 right triangle, or the pi over 3, pi over 6, pi over 2 triangle. And this time, instead of the pi over 6's, we have it on the pi over 3's. So that means our 60-degree angle, or our pi over 3 angle, is the internal angle, and that makes the long legs vertical. So sine of 2 pi over 3 is going to be the square root of 3 over 2, opposite over hypotenuse. So square root of 3 over 2. Notice once again sine is positive because it's up. Cosine of 4 pi over 3, adjacent over hypotenuse, which is negative 1 over 2. Why is it negative? Because it's left. And tangent 5 pi over 3 is going to be opposite over adjacent, which is negative square root of 3 over 1, which equals just plain negative square root of 3. Now, why is that negative? Same reason as before, sine and cosine are opposite signs. So, the key thing is getting these triangles etched in your mind so that I could give you any special angle anywhere around the unit circle in radians, and you could tell me sine, cosine, tangent, secant, cosecant, cotangent of any of them. That's it. Have fun with these.
That's all, folks.